Who is this Lenovo K6 Power? If your name or USN is not there, I cannot admit you. Okay. From next week, your computer-aided detailing of structure lab will be starting. So I just want to give some instruction on that lab so that you'll get more time to work on AutoCAD when you are here. Okay, we'll be having instruction in our physical class also, those who are attending the physical class. So other than that, those who are unable to attend the physical class, okay, so they can also try on their laptops. And even for the physical class, you can get your laptops. If you don't want to use the systems in the computer lab, you can come with your own laptops if you have. No need to purchase new one. We are providing that in the lab facility. But still, if you want to use your own laptops, you can come with them. And others, they can practice on their own when they are at home only, if they are not able to come over here to the lab. Okay, so we'll start with the uh, syllabus over here. Okay, so let me uh, show you what all things are there in this particular lab. Okay, so it will be a computer-aided detailing lab of structures, and you'll be having both RCC as well as steel structure. And you have already come across the design of these components. You have designed the beams, simply supported beam, okay, and continuous beam or a continuous slab you might have designed, okay, and one way and two way slab you have come across these design in your previous semesters, and also the design of staircase. In present semester, you have studied about design of retaining wall, that is cantilever retaining wall and counterport retaining wall, and also you are having circular and rectangular water tanks here. Okay, so this is the RCC part. You'll be doing the detailing of these components: beams, slabs, staircase, and retaining wall, and the water tanks. Okay, this is what you have as per your syllabus over here. Now, in case of steel, this part, okay, there will be two parts in this, that is module 1 and module 2. In second module, you'll be coming across the detailing of steel structures. Okay, so here the connection details. The first thing what we'll be dealing is with the connection details, that is beam to beam connection or beam to column connection, both welded as well as bolted connections we'll be taking up. And further part is about built up columns. Okay, so we have uh, taken up these design of built up columns with lacing and pattern systems. Okay, so these details will be prepared in this particular lab over here, details of those built up columns, and also the details of column bases, that is the slab base and the gusseted base. We have it in the detailing, and roof truss, which we have already designed in this semester. The truss, whatever we have designed for the same, we can will be doing the detailing. And what you have is the welded or bolted plate girder and the gantry girder. Okay, so these are all the members for which you need to prepare the detailed drawing, right? So due to time limitation, we will restrict ourselves. We may not be able to cover the entire things. Okay, so but you will be given instruction regarding them so that you have a knowledge of detailing of all the components. Okay, we'll limit our drawings to some selected drawings over here. So what I'll do is in this present session, I'll be telling you about the detailing of simply supported beam. Okay, we'll be meeting till next week in a short session of 15-20 minutes, and we'll be covering up the detailing part, the instruction or explanation part. And in the lab, when you come for the lab in the next week from Monday, it is starting, you'll be starting immediately with the AutoCAD. Okay, you have any difficulty or doubt, that will be resolved over there. but I want to save some time with these instruction classes. Now, in case of a simply supported beam, this is a module 1 RCC part. This is where we'll start the RCC part. Okay, that is with the detailing of simply supported beam. Now, whatever details I am showing here, these figures, they are taken from SP34. Okay, so it is a guideline for detailing of reinforced concrete structures. You'll find all these drawings in SP34. Like you have SP16 design aids for RC structures. SP34 is for the detailing of reinforcement in RC structure. Okay, so this is a simply supported beam. Okay, now what you find in a simply supported beam is the main reinforcement will be provided on the bottom side. That is, tension will be arising at the bottom under sagging moment. So what you have is the main reinforcement will be provided over here on the bottom or the at the soffit of the beam. Okay, so these are the main bars what you are seeing here at the bottom. On the top side, okay, you'll be having hanger bars. If at all, if it is a doubly reinforced section, there may be bars provided to take up the stresses over there, or else at least the hanger bars have to be provided on the top side, which will help us to hold the stirrup in their position. Okay, to hold whatever stirrup or shear reinforcement we provide over here, so that will be held in position with the help of these hanger bars. So at least minimum 2 bars are required on the top side, which will act as a hanger bars. So top minimum 2 bars will be there. Okay, so that is the minimum 2 bars what has been mentioned over here. If not, if design requirements are there to take up negative movement or hogging movement, or if it is a doubly reinforced beam, then you'll be coming across main reinforcement on the top side also. You may have the main reinforcement on the top side also here. Okay, if not, at least 2 bars are required to hold the stirrups in position. Right, on the bottom side, we'll come to the main reinforcement. So here in the mid span, you'll require the full AST, that is 100% AST. We'll be designing the simply supported beam for the maximum embedment at the mid span. There 100% of AST will be required. So that 100% has been mentioned over here. As you move towards the support, the movement, bending movement will reduce to 0. So here we don't require 100% of the total AST. So that can be curtailed, that can be reduced. Now question is where we can reduce that and how much amount can be reduced. Okay, so that has been shown here. So you can reduce it by 50%. At what distance? At a distance of 0.08 L from the face of the support. L is our center to center distance between the support. This is the span of the beam, center to center distance between the support. Okay, so after a distance of 0.08 L from the face of this support, I can cut 50% of the steel on both the supports. Okay, so that will help us to save the quantity of steel. Okay, so that is the purpose of curtailment over here. So this 50% curtailment can be done only after a distance of 0.08 L from our support over here. Okay, so say for example, I have about 5 bars over here. Okay, 5 bars in the center. It may be of any diameter. I'm just talking about numbers, 5 bars. So when I move towards the support at a distance of 0.08 L, when I come into this range, okay, 0.08 L, in this portion, I can curtail 2 bars, okay? So 50% can be curtailed, not more than 50%. So what I'm able to do out of 5, I can stop 2 bars over here. 3 have to be continued up to the support, okay? And they should extend within the support to a distance of LD by 3. LD is the development length. We'll get the development length based on bond stress, diameter of bar, and the uh, grade of steel over there. Okay, there is a calculation for that, but we can get LD, that is there. But what has to happen? These bars, whatever the main bars are provided, they should extend to a distance of LD by 3 within the support. So that has been shown here. So when you are preparing the details of a simply supported beam, you'll be provided with the reinforcement details. What number of bars are there at the bottom? What is their diameter? What number of bars are at the top? What is their diameter will be provided to you. Along with this, the span of the beam as well as the support width will be mentioned over there in the question. With the help of these, you have to come up with this detailing. Okay, that is, you need to decide what is the distance of curtailment, what number of bars have been curtailed, that has to be done. Along with this, you also come across the stirrups. In this particular figure, what you are seeing now, stirrups have not been shown here for purpose of clarity, but shear reinforcement stirrups will be provided over here. Okay, within this span. So there may be two-legged vertical stirrups and of some diameter, so they will be spaced at some center to center distance. Okay, so this is about the simply supported beam. Is that fine? So what bars, top bars will be there? They may be main reinforcement or compression reinforcement, or in if not, at least two bars will be provided. If it is not mentioned what is the number of top bars, you have to provide two bars over there. Okay, for the hanger as a hanger bars. Okay, and on the bottom side, what you have at the mid span, 100% of EST will be provided there. And as you move towards the support, after a distance of 0.08 times L, we can curtail 50% of reinforcement, not more than 50%. We can curtail up to 50% of the reinforcement what is provided at the midspan. Okay, and rest of that has to extend to a distance of LD by 3 within the support. LD is our development length in tension. Okay, so that is the simply supported beam what we have. So further, okay, this is one drawing what you can see here, what has been prepared. Now here you can see four bars are there. Four bars of 16 mm diameter are provided at the support. This will be given in the form of a statement to you in this lab. Okay. With that, you have to prepare all these details. So I'll tell you the question once you are in the lab. There I'll give you that. Here you see main bars are four bars of 16 mm diameter. Okay. And when you move towards the support, two of them have been bent up. Okay. Curtailment can be done or bent up can also be used. Look for what has been given in your question and follow that one. Okay, so here bent up has been done. So two bars can be bent. It is just like curtailing 50%. So 50% is available beyond this distance, 0.018 L. Okay, so that is the distance what you need to consider. So you need to calculate how much that comes out. In this case, 0.08 into this will be 5 meter. That is center to center distance between the support. 4700 plus 300 by 2 plus 300 by 2. That is 4700 plus 300, which comes out as 5000. So 0.08 into 5000 will come out to be 400 mm. Okay. So after this distance, I'll not take up this bent up. This is uh, one detailing what I wanted to show you. So after this distance, what is shown here, after a distance of 400 mm, okay, I can curtail 50% over here. That is two bars I can stop. Rest should extend up to a distance of LD by 3 over here. Okay, so that is what you have. Now, after that, on top, if you look, two bars of 10 mm diameter. These are the hanger bars. Okay, what have been provided. Now, shear reinforcement, what is there? 8 mm stirrups at 150 mm center to center. Okay, that is two-legged vertical stirrups at 150 mm center to center. So these, whether they are two-legged, what is their spacing, will be given for you in the question. Okay, only thing is you have to prepare the drawing. The question, what will be given to you, statement that should be converted into a drawing over there. Okay, so top hanger bars, bottom bars, four bars of 16 mm dia, out of which two have been bent up in this case. Okay, so that is what you have in this longitudinal section over here. Other than that, what is the clear span is here 4700, support width 300 mm will be shown in dimensioning. Okay, so that is what you need to do, and depth of the beam is 450 mm. So this end cover is 50 mm here. Okay, we'll we'll be having the end cover of 50 mm. Rest other, what about the cover to the main reinforcement? In case of beam, 25 mm cover. Okay, if not given, take it to be 25 mm. The cover to the main reinforcement or the hanger bars, it should be 25 mm for beams. Okay, now what we have is this is the longitudinal section. Okay, other than this, we need to prepare the cross section also. Where do I require the cross section? One cross section should be over here at the center. Another cross section after the bent up or after the curtailment. Okay, because the bar positions will be changing over there. So we will be showing the cross sections, details in the cross section at such locations whenever you have the curtailment. Okay, after that and before that, the cross sections will be taken over there. So here the cross section at A, it is at the midspan. So you can see at the bottom 4 bars of 16 diameter have been shown here. And these are two-legged vertical stirrups. 2 LVS means two-legged vertical stirrups. One leg, this vertical leg, and another vertical leg. Okay, so two-legged vertical stirrups of 8 diameter at 150 center to center. They are provided at 150 center to center along this span. Okay, what is the width of the beam? It is 230 The width of the beam can be seen in this cross section. So this is 230 Depth, you can see 450 Even in longitudinal section, you need to show this depth over here. Okay, so top 2 bars, hanger bars are here. The same cross section when you after the curtailment or after the bent up, this is actually cross section at BB over here near the support. Okay, what happens over here? So since 2 bars have been curtailed or bent up, on the bottom face, you are left with only 2 bars of 16 diameter. From 4, now it has become 2 bars of 16 diameter. Okay, and the shear reinforcement will remain same. 2-legged vertical steps of 8 diameter at 150 center to center will be provided there. And at the support, what will happen on the top side? Okay, see, in this case, the bent up have been used. So what happens is the 2 bars will go to the top now after the bent up. Okay, this was a practice earlier, bent up bars, having a bent up bars. Nowadays we don't go for giving the bent up bars. Okay, normally curtailment is preferred over the bent up. Okay, if you visit us any site nowadays, they prefer to have curtailment of the bars. Okay, so these are bent up bars. The purpose what was behind this is they also serve as a shear reinforcement. It was there, but their effectiveness is not as good as the stirrups. So for that purpose, this bent up has been uh, not been used or practiced nowadays. So what happened here is due to bent up, 2 bars are coming to the top. 2 bars of 16 diameter are coming to the top. Okay, so this is actually 2 bars of 16 diameter over here in the center, which are coming due to the bent up. Okay, and 2 bars of 10 dia are hanger bars. Okay, please take this correction. This is what? This is the 2. This is not 4. This is 2 over here. Okay, so that is 2. So this is what you have here. 2. Okay, sorry, it may not be visible, but take that correction from me. 2 bars of 16 dia, which are due to bent up. They are appearing on the top side now. Okay, other than that, 2 bars of 10 dia will be running throughout the beam. They are the hanger bars. They will be running throughout the beam continuously. Okay, so this is what the our simply supported beam is. Detailing of simply supported beam is. Okay, is it fine? If you have understood this, or if you want to make anything clear, please tell me. If you have your own laptop, go for practicing this one. Okay, I'll just share this image. Okay, and you can practice directly the same image itself. Okay, no, instead of question, the same image you can practice. Okay, and let me take this continuous beam also. It is as good. We can finish this one. So in case of continuous beam, the beam will be running over the continuous supports. One after the other, there will be supports. So here, the curtailment, what you find, there will be, you will be coming across more number of curtailments over here. So what you have here, bottom steel, 100%. How to read this actually from SP34? See, bottom steel, 100%. When you come towards the support at a distance of 0.1 L1, 0.1 L1 means refer to this first span, 0.1 L1. From the center of the support, 0.1 L1. In this distance, you can curtail what 70% of the steel. See here, 30%. From 100, it has reduced to 30%. Okay, so that can be done over here. In case of continuous beam, that is what you have over here. So we can curtail 30%. What should be available? That has been shown. So 30% should be available here. So you can curtail 70% of the steel. Okay, you can just roughly calculate. If you have say 6 number of bars at the center, what will be 70% curtailment? Okay, 6 into 7. Okay, that comes out as 42 or 4.2 bars. You can curtail 4 bars. 2 you can extend it to the support over here. That is how you have to roughly come up with the curtailment. Okay, but at least 30% should be available here, not less than 30%. Okay, so that is what you have on the bottom side. So this 30%, where you can do the curtailment, 0.1 for the end support, it is 0.1 L1, 0.1 times the effective span, the first span. Okay, this is curtailment details for a continuous beam. Okay, I am talking about the first support, first exterior support here, 0.1 L1. Now, interior support, what they have mentioned, 0.15 L1. I can curtail the bars at a distance of 0.15 L1 from the center of the support. How much should be available after curtailment? 30%. Okay. Similarly, on the other side, what we have? 0.15 L2. This is the interior support now. Now we have come to the interior support. For exterior support, bottom steel, curtailment distance is 0.1 L1. Interior support, bottom steel, curtailment distance is 0.15 L1 or L2 over here. Okay. How much percentage should be available after curtailment? 30%. Okay, that is what you have. So this is what it is. Other interior support, it will continue. Same. This will repeat. This is for interior support. The same thing will repeat in the other interior support. So this is about the bottom steel here now. Now coming to the top steel, what you have in case of top steel. So at the supports, we require the top steel. So 100% should be available at the support. This is to take care of hogging movement. So hogging movement will cause tension on the top side, on the top face of the beam. So for that purpose, at the supports, 100% should be available over here. As you move away from the support, okay, step by step, you can curtail this. How they have given, see, for the end support, from the face of the support, this line, it is coming to the face of the support over here. From the face of the support, the first curtailment can be done after 0.1 L1 distance. After 0.1 L1 distance. Okay. Understand to read this SP34 drawings. So how much I can curtail in first step? I can curtail 40%. After curtailment, what is there? Here 60% should be available. So I can curtail 40% here, right? The second curtailment point will be 0.25 L1. Okay, 0.25 L1. So after this second curtailment point, how much should be available? 20% should be available. That is, I can curtail 80% over here. After 0.25 L1, I can curtail 80%. 20% of this top reinforcement, what is required at the support, should be available here. Okay, so that is how you have to read these drawings and understand them and prepare our reinforcement details for our design. Okay, now this is the end support what you have. I'll come to this early later. This is the end support. This is the curtailment what I'm dealing first. Okay, bottom we are seeing and top. Okay, top main reinforcement, 100% of main reinforcement is required at the support. As you move away from the support, you can go for curtailment. Okay, so that is what it was shown over here. Whereas on the other hand, at the bottom of the beam, 100% of the steel, 100% of the beam steel is required at the mid span. As you move towards the support, you can go for curtailment. Okay, that is due to changing movement. Okay, and coming to the interior support, top reinforcement. Near the center of the support, you require 100% of steel over here on both sides. Continuity is there. Okay, so 100% and 100%. At a distance of 0.15 L1 or on this side 0.15 L2, you can go for curtailment of 40%. After curtailment, 60% is available. So 40% can be curtailed. After a distance of 0.25 L1 or on this side 0.25 L2, again you can curtail further 40% or you can go for curtailment of 80%, after which 20% should be available. Okay, or at least minimum 2 bars should be available as a hanger bar to support the stirrups. Okay, so that is the curtailment details. So I hope you can now you'll be able to read these SP34 details. Sit, go through this SP34 detailing. When problem is given to you, you should be able to do these calculations: 0.15 L1, 0.25 L1, or this 0.15 L2, zero point 0.1 L1. Okay, you'll get to know. If I give you the span of the beam, you can calculate what is 0.15 L1. 5 meter span, 0.15 L1, 500 mm. Okay, so after a distance of 0.500 mm, you'll go for curtailment here. Like that, you'll be able to come up with the calculation. You need to remember these things. Okay, bottom, top, curtailment points. How much is the percentage of curtailment? That should be there in your mind. Okay, so this is a curtailment. Now what is shown here is LD, development length. Okay, so this top reinforcement should extend within this support. Okay, for a distance of LD over here. Okay, so this will help to develop the required bond stress over there, or it will hold the bar. It is the development length what is required for that purpose. So LD is required within this support over here. Fine. So other than this, you'll be having the stirrups also in this case. They are not shown the stirrups here, but stirrups will be present, so present over there. Okay, so these are the two beams what we'll take up in the first lab. Just go through this. I'll share this PPT itself to you. Sit and go through that. There are some correction. So just in this case, 2 bars. Okay, like that corrections are there. So you can just ignore that. But what I want you to do is read these SP34 drawings. Understand these SP34 detailing drawings. Okay, so that is the main thing. And this is a simply supported beam. What I shown. This is a continuous beam. This is how you will be preparing the CAD drawings. Just have a look at these. I'll not share this itself directly. There are some corrections in this. So, but this is how your drawing will be. You are familiar with the AutoCAD commands and all. Only thing is you have to sit and work with these drawings. Okay. So one thing what you can do directly now is take this, try practicing this only, this beam only. Okay. So I'll finish this. Tomorrow I'll tell you the time when we can join. We'll have 15-20 minutes session on the lab, and later we can have physical lab also. So when you come over here, others with your laptop you can keep working at your home if you are not here. Okay. If you have any doubts, you can please unmute and ask yourself. Ask me, unmute yourself. Okay. Else you can finish it over here. Okay. You can exit if you don't have any doubt. I'll end the meeting.